Hi everybody, Susan here.
Rohan here. So we are, our experiment is about the Kelvin water drop generator, and it's done by, basically what we're trying to show is how to produce static electricity from two potentials that are building up with charge.
Well, so I'll be explaining the apparatus, the precaution and assumption part of the experiment, whereas Rohan will be explaining more of the theoretical side of the entire thing.
Thanks. See you.
Hi guys, this is our version of the Kelvin water drop experiment, and I'll be the one telling you basically how do you put it up basically. So as you can see, what just happened is you put water in the reservoir on the top, and make sure that the reservoir can be plastic, just make sure it does not conduct electricity on any other surface. That is why it's on a non-metallic chair, as you can see. And as you can see here, you can see water droplets coming like in a steady flow from the top. I am both on the left, which is I am right at now, and on the right. And as you can see, there's this wire clipping, but I'll go to that later. But you see the tape there? Yeah, that's the tape that basically just holds it. And I'm very sorry about the water droplets at the bottom, because, well, it's kind of hard to get at a particular point, but anyway, I can still explain it. So, well, I'll be explaining why do I use this equipment first. Well, first, obviously, some parts must be metallic, like the tin can you see, so you can connect electricity from one point to another. So, well, this is the overview of the entire thing. And as you can see, I'm sorry, you cannot see it actually. There isn't actually electricity in between. Well, the hole is too small, but it's alright. But as you can hear, I've increased the capacity of you hearing the sound of the spark, which is the main point of our experiment here. So, as you can see, my left metallic can, which is suspended, is currently kind of like the water droplet is kind of like going through it, as you can see. And as you can see right now, the bottom from previously, the bottom line of the water is in individual droplets. You cannot see it very clearly that it's individual droplets, but if you actually have, well, I don't have a high-speed camera, but you can use a high-speed camera and actually try it out. Just make sure for this experiment to work, the top part is in individual flows, whereas the bottom the top part is a continuous flow of water, whereas the bottom part is basically individual drops. Maybe it's just very fast. Ooh, okay. The water is kind of flowing. Let me fill this up. Hold on a second. Alright, now I change the water. Oh yeah, I make sure one more thing. That the exterior parts of the cans are not wet. Why? Because, well, my friend Rohan will explain to me later, hopefully. And anyway, my reason here to use this duct tape there, back just now on the top, is because, well, duct tape doesn't really conduct a lot of electricity, but even though it does, I use the duct tape to connect to the reservoir, which is plastic, so it does not conduct that much electricity. Well, in a sense, yeah. And as you can see, I have the green colored kind of container containing the two tin cans. This is because I'm preventing any possible charges exchange between the tin cans on the floor to the ground. As you can see just now, there are two metal balls there. Obviously, the metal balls must be able to conduct electricity for this experiment to work. As you can see, the wires can be a little messed up, but of course we have to like adjust it. And as you can see here, I'm going to actually very much try to adjust this tape. Another reason why I use duct tape is because, well, as you can see here, I can like adjust it as much as I want. But of course, another way to improve this instead of using duct tape is to basically hammer, nails, and wood into it, and then you can put a rubber band to hold the tin in place. Because one flaw of this experiment is that, as you can see, it kind of like loses its stickiness. The duct tape obviously loses its stickiness, so it's not that well. Well, as you can see here, the metal cans outside is a little wet. So as I said before, maybe in a chance for this experiment to work, make sure that they are not wet. As you can see, the ball here, yeah, they are on a plastic container. This is to prevent electrical charge escaping this circuit of ours, so that all the charges stay in place. Well, this is basically the entire thing. Thank you.
So this is just for illustration purposes of our Kelvin water drop generator. And what I'm going to do is just show basically how the charge is flowing from and how we actually generate the static electricity. So in a perfect world where most things are generally neutral, but we're going to say that of course this is real life, it's not perfect. So let's assume that in this case where all the cans are supposed to be neutral, one of them is slightly more negatively charged. So let's say this one is slightly more negatively charged. So overall it possesses a negative charge. Now since it's connected, by connecting wires to this can, this one then becomes more negatively charged as well. Now what's happening is that a stream of water, which is flowing from the reservoir on the right side, is flowing through can B. And as it comes out to can B, it's actually lessening in terms of the flow, and it's actually deflecting a little. And the reason for that is because since this can is negatively charged, and the water droplets of course have positive and negative charge, what's happening then is the negative charge in the water droplets is being repelled, and the only place it can go, since it can't really go here, is up. So negative charge builds up on this side of the reservoir as it goes up this way, and positive charge, which is what is remaining in the water droplets, falls down with the water droplets and comes to this can, making this can more positively charged over time. Now since this can is connected to this one, again over time the positive charges flow, and we have a positive charge here. And here as well, just like on this side, except now with positive charge, the water stream which is flowing has both positive and negative. The negative charges, the positive charges are now repelled and flow up towards the stream, making this side more positively charged. And we have negative charges flowing this way, making this one again more positively charged. More negatively charged. So as you see, what will happen over time is that this one builds a higher concentration of negative charges, this one a higher concentration of positive charges. These two cans are now connected using connecting wires, and there's this setup here where two conducting metal balls are in place, and what will happen is eventually this one builds up more negative charge, this one builds up more positive charge, and what we have is a situation where at one point after the charges build up to a certain level, sometimes we see a spark, or at least we hear it. And in our experiment, you'll at least see that we hear it, because seeing it is quite difficult based on the fact that the charges are really minute. So yeah, in the end that just generates a little zzz, or however you like to see it. And yeah, so that's basically the illustration of the Kelvin water drop generator.